Welcome to Barcelona, by the way. It is absolutely fantastic to see so many of you back here. I've been here for 7 days already, and the good news is every single person I've met has been glad to see me. Not because it's me, because they're just glad to see another living human being. As you can tell on the show floor, we're not quite where we were 2019, but there's a nice buzz down there, things are coming back, and everybody is generally glad to be back at another MWC. So I'm Alex Sinclair, I'm the CTO of the GSMA, and I'm here to talk to you a little bit about mmWave. So look, we all know, and you all know, that 5G is an excellent opportunity. Our own GSMA intelligence unit estimates that by 2025 we'll have around 2.3 billion 5G smartphones, 4 billion cellular IoT connections, and all of that will contribute around $4.5 trillion to the global economy. If you caught the keynote on Monday with my boss, the Director General, Mats Granryd, he's already said that this will be the year that we reach the first billion milestone for 5G, and that's pretty impressive. But you also know, hopefully, if you don't, you should by the end of this session, how important mmWave is in delivering increased bandwidth, fast data speeds, and low latency. This particularly benefits densely populated high traffic areas, things like sports stadia, venues, campuses, that sort of stuff. And it's a pretty cost-effective way to increase your network capacity. It's like literally adding 8 times the number of lanes to a highway or motorway. It also facilitates the expansion, some of it's already happening, but into new areas, and we've got people already doing it, into things like fixed wireless access and fiber-like speeds, which is also fantastic. Now, you're going to need devices as well. According to the GSA, there are about 186 networks in 45 countries that are in some way investing in mmWave, might be acquiring licenses, tests, trials, deployments, and there are more than 150 pre-commercial and commercial devices already supporting mmWave. Again, according to our own intelligence unit, a combined mmWave and 3.5 gig network can run out at about 35% savings in TCO compared to just using sub-6 spectrum. Now, we have a great lineup for you this morning. We're going to hear from operators, vendors, analysts, how 5G mmWave is key to unlocking the full potential of 5G. We're going to hear about the progress we've had to date on our initiatives, the global outlook, the business applications and use cases that we covered, as well, of course, as the challenges, priorities, and next steps. A number of this morning's speakers are already represented as part of a new GSMA initiative. It's our mmWave Accelerator initiative that's aiming to explore the role that 5G mmWave will play. And you can see some of the logos behind me. And if you get a chance, please come to our stand, the GSMA stand in Hall 4, where we're also exhibiting a number of these things as well. But to get things started, I'd like to introduce you to a real mmWave advocate and zealot, and that's Philippe Poggianti from Qualcomm's Global Head of mmWave, to talk to us about how critical 2022 is for this technology. Enjoy the rest of the session. Thanks very much for coming. Philippe, over to you.
Thank you, Alex. Good morning, everybody. So as usual, the difficult part is the mask handling. Can you hear me well?
Yes.
Okay, good. So yeah, welcome to be here to talk about mmWave. So let's dive directly into it. I think this year is the year of mmWave key decisions in many parts of the world, actually in the whole world, and I will articulate why those decisions are so important. The mmWave, in complement to sub-6, to mid-band, has the potential to redefine the mobile experiences. When you want to look at the maturity of a technology, this is usually what we are being asked when we talk 5G mmWave. We can look at different dimensions, and I will go through each of these dimensions to assess together what's the level of maturity that we can expect. So first thing that the people will ask is there spectrum available? That's the first thing first. That's the role of the governments, of the regulators, and this is extremely important. As Alex said, 8 lanes for a highway is much better than 1 lane. So the spectrum of mmWave in the 4 3GPP bands and more to come later is abundant and available, and usually the price per megahertz is usually cheaper than other sorts. So we have the possibility now to have more spectrum. And what do we do with it? In this world map, that has really evolved a lot in the past 1 year. 1 year ago, I would have shown this map. It was a little bit empty, and now it's popping up. 2 dimensions in this map. The dimensions of the governments, as I said, so they are going to take, or they have taken recently, big, I would say, decisions to allocate, or they will allocate millimeter wave spectrum. Let me give you a few examples. The millimeter wave spectrum started with 28 gigahertz in the US and in Japan, and I will not go to the details of the 3GPP bands, you know them. But now we see an emergence of the 26 gigahertz, so the N258, in Australia, in Europe, in Latin America, in Middle East, and very soon in India and in China. So this is the first, I would say, key message, is that governments are extremely active in doing consultation and allocating spectrum. Then the second thing that you notice, of course, is the extensive commercialization. Definitely the US and Japan are leading the way, no question about that. All operators in Japan, as an example, all 4 MNOs in Japan have launched commercially, and they have deployed more than 17,000 base stations or cells, according to the Ministry of Information and Communication, throughout Japan, of millimeter wave, in complement to sub-6. So these are, I would say, the poster childs, the countries where millimeter wave is a reality. What we are seeing also now, from you can see this arc of Asia-Pacific countries. From Korea, we will have a person from the Ministry of Science and ICT speaking. It will be super interesting to hear from Korea. We will have a person speaking from Telstra today to explain what type of use cases they are going to launch, and that will be great. As an example, we are moving from fixed wireless access to mobile broadband and to private networks in this arc, I would say, of Asia-Pacific. And then soon, in Europe, you will hear from Fastweb CTO. He could not come today, but you see the launch in Italy is from Fastweb in Italy, like fiber-like speed for fixed wireless access, and more coming from them. You will hear them at the end. So that was the second, I would say, dimension. First was the spectrum. Is there a spectrum? The answer is yes. Second, is there a take-up from the operator? The answer is yes. The third piece of the equation, when you assess the maturity of an ecosystem, will obviously be, are there devices? And Alex mentioned the GSA assessment that they are doing on a regular basis. 150 plus devices of all kinds. What is really, in my view, there are 2 striking things in this slide. The fact that the form factors are very different. You know, you can have an always connected PC like the Lenovo X13S that has been launched at the World Congress is just one of the many examples where always connected PC embed 5G sub-6 and 5G millimeter wave in selected markets for this form factor. You have fixed wireless access CPEs, you have devices of all kinds. And the second dimension is the fact that there are 50 plus vendors, different vendors, so it's a vibrant community. It's not just the big names, it's not just the small names, it's all the names that are famous to build those devices. And the result is the analysts are forecasting such a growth of, so just focusing on the smartphones here, this is the intelligence we have from the analyst forecast. They estimate to have like a 60% CAGR growth in the coming 2 years. So from 21 to 23, 60% yearly growth on the next 2 years, which will lead to one smartphone out of 5 at the end of 23 will be millimeter wave enabled according to their, so it's an average of the 4 analysts that are at the bottom of this slide. And this is refreshing because when you think about it, millimeter wave, if you are an operator in the room, you want, your premium customers to start to benefit from it, and then after it will cascade to your, high tier and value tier customers little by little. So when you reach 20% penetration of the total 5G market, it means that by the end of 2023, it means virtually all premium users will have a millimeter wave in their pocket. Now we need to invent what comes with it. So after the third dimension, which is the ecosystem, the fourth dimension will be the use cases, obviously. Every conversation I have around millimeter wave will be, the use cases. So the way we see it at Qualcomm is to have homes, of course, and to provide a journey for the consumer, more for the prosumer, in high-density locations. So this is why you are seeing, these transit hubs, very busy train stations, offices. It can be universities, it can be hospitals, it can be, first responder centers. Outdoor hot zones, we go outside for lunch, for dinner, etc., in busy places, and we go indoor also. So it's a indoor and outdoor type of deployments, but in very selected areas. And of course, the next question that we want to answer is the business case. And Stephen will come to that in a minute to show that when we deploy millimeter wave in those type of high density locations, the business case will prove positive for an operator. So that will be the fifth dimension, I would say, for the millimeter wave assessment of the maturity. The good news with millimeter wave, I touched upon it, is the versatility of the technology, the fact that it is adaptable to many use cases. So we have announced, for example, the importance of high-power CPEs for fixed wireless access. The importance is not too much the breaking the record. Breaking a record is it's a one-shot. But what is important is that Verizon, as an example, is using it for 5G home to bridge the digital divide in the US. And this is critical for the benefit of the society. And importantly, we have just announced the standalone FR2 only millimeter wave. You will hear the CTO of Fastweb using FR2, so a frequency range 2 millimeter wave only standalone, which is critical for fixed wireless access for the providers who don't have access to the sub-6 spectrum, and also for private networks, it is important. On the right-hand side, you see mobile broadband. So it's equally important to use dual connectivity to benefit from both sub-6 and millimeter wave together for the best user experience. So what do you achieve as the best user experience is that it's a complex slide. Forget about, again, the big peak throughput. We know that millimeter wave with 800 megahertz of bandwidth will reach this big throughput. What I wanted to highlight for you is this root matrix analysis, is that when you are in a non-congested area for mid-band, you can have the same type of quality of experience when you are in a congested area with millimeter wave. So it means the key message, if I was a marketing, I'm not a marketing guy, if I was a marketing guy of an operator, my motto would be to really offer the seamless quality of experience wherever you are. So the best possible QoE. And then last but not least, private networks. So I'm sure a few of you will talk about it. So I go relatively quickly here. Indoor private networks, because it's isolate millimeter wave frequency isolates quite well from the umbrella mobile network, and also outdoor in a port authority or in an airport. We have a lot of use cases where you need like a data shower or data offload extremely quickly from an engine of a plane, for example, when they are taxiing and they need immediately to transfer all the data from the engine to the airport's operating center as an example. So many use cases that will flourish in Korea, in Taiwan, in Singapore. We have many of those activities around private networks powered by millimeter wave. So that was really just a quick intro to say, we don't see 5G millimeter wave as a technology per se. Don't forget, it's a frequency band inside the family of 5G. But what a frequency band? What does it unleash as a possibility? And with that, the maturity of the ecosystem being ready, I think now we can complete the 5G puzzle. Thank you very much.
Thank you very much, Philippe. I'm Colin Barham, Head of Marketing and Partnerships at the GSMA, and it's my pleasure to introduce our next speaker, Stephen Rose, who's Senior Partner, Global Head of Telco at Bell Labs.
That's great. Can you hear me okay? Yeah, great, excellent. All right, so thanks very much. I think it's been a fascinating couple of days here. I think there are a couple of things that I've observed whilst being here at the Mobile World Congress. One is that it's almost like we've been sat in a room for 2 years. Yeah. And the reason being is we've actually spent that time thinking deeply about what is the potential for the different technologies that we have got access to. And that's actually, that thinking time has enabled us to process a lot of thought and do a lot of analysis, and that's what we're going to do today. I think the other thing is obviously there are a number of other topics about rich experience, and clearly this type of technology provides foundations for richer experience around Metaverse, Web 3.0, as well as enterprise. So it's very, very exciting times, and I think it's a timely discussion. We set about to prove that there was a case for millimeter wave. The reason why we were doing that, of course, is because there have been some discussions around whether it's sub-6 or whether it's millimeter wave, and we don't think that's the right discussion. We think it's and how do you actually then make them complementary technologies? It's a very important point. So we really wanted to understand in small amounts of detail, very small amounts of detail, where could the technology be deployed, and in what would be the underlying drivers for making this a profitable outcome for the operators. So we all know the challenges on the left-hand side, you know, they're well documented and well discussed, whether it be issues of coverage or propagation, and there was some historical issues around the ecosystem, and I think Philippe there just cleared that issue up, in fact. But of course, again, all of the other things were becoming clearer and clearer, or have become clearer to us around capacity and around where it should be surgically deployed. And the case was then really, where is the business attractiveness? Very important to understand that in detail. Now, what we do understand is there is a direct correlation, generally speaking, between higher frequency bands, higher offers in terms of tariff structures and Net Promoter Score. And if we have a look here on the left-hand side, we can see LGU Plus and we can see Verizon. And what's been happening is just generally speaking on 5G, as customers are taking on higher plans and higher speeds and feeds, there is a willingness to pay. So that's fantastic. You have to establish that as a baseline, and that's what we've done. The question is, what more can you do with that? And I think it's very important that actually as subscribers move from different types of technologies, so if they're moving from 5G onto millimeter wave, they're actually very conscious of that. That's one of the things that we probably have to think about a little bit more. Am I roaming into a particular, or am I moving into a zone, and does that zone give me an experience that is unique and differentiated well above the norm, well above the 5G norm? And clearly millimeter wave does. So there is an opportunity there. The second thing that we did is we actually, the other thing that we did is we had a look at where were the use cases. And you can see there is an absolutely enormous shift in the amount of traffic. So this was actually analyzed across 6 different European markets. And in those 6 different European markets, we took these different zones, and we actually correlated that with about 150 different use cases. So we were really testing this in a lot of detail. And what we figured out in the end was there is enormous traffic demand, and you have to serve that. Okay? And there's a revenue opportunity that clearly goes along with that. So that 129% times all of the different markets that we were talking about, that's where the opportunity lies. So whether you're an enterprise customer that's able to serve in a particular business scenario, or whether you're a CSP serving that particular customer, that's where the opportunity is. The second thing we did is we looked at actually where was the revenue opportunity for that. So we converted a series of the materials into actually where's the willingness to pay. And again, you can see here underserved locations, We've got the office space. We've got 150 train stations that we can deploy to, and then all of these other different options here. And what we found in this particular scenario here was an 8% increase in revenue over the 5 years. That's a very, very attractive business case. And there aren't too many opportunities like that we see with the other 5G technologies, because of the way in which, if you're going to offer an all-you-can-eat tariff, you get an incremental growth on the original tariff, but this is an accelerator, or this is an additive technological opportunity, or technologically enabled opportunity. The key for this is finding the sweet spot. And what we found is that there was a range of about 1,000 to 3,000 subscribers per hot zone, and that was where the sweet spot was. And we'll go through an individual case in a minute on Gare du Nord. If you go lower than 1,000, naturally you have a far less attractive business case. If you go more than 3,000 subscribers, then you actually have to start considering alternative options. So it is very important, and that was one of the learning outcomes from this. When you're deploying this technology, or you're considering to deploy this technology, you really need to go into micro levels of detail, or reasonably micro levels of detail, to understand how people are moving within a specific environment, what is the kind of behavior, and what kind of behavior do you want to promote, and are there other applications that you can actually push towards the customer that would enable them to rethink about the experience that they're actually delivering. But as I said earlier as well, the consciousness around the experience is extremely important. So in this scenario here, we could see on the left-hand side, 75% less cost per gigabit, I should say, versus sub-6 in the hot zones. This was the case for Gare du Nord. Very, very attractive. Seems fairly obvious if you think of just about the array, the way in which the array would actually be deployed. So we were very excited about that. Second thing that we found was that you were able to actually incorporate multiple strategies to position and upsell the technology. So if you're selling this in a retail experience in a certain sense, or a B2C experience in Gare du Nord, obviously the train operator in Gare du Nord can also then consider the opportunities to actually bring that into their own enterprise organization. So again, many, many different opportunities to move that around. But on this particular case, that did not consider that. We only considered the B2C instance. But lots of opportunity if we think laterally, and if we think also in a certain time with standards evolution, we'd expect that there to be a multi-tenanted option around this as well. So again, this business case could become even more attractive. And the last point here was the payback period, less than 4 years, and return on invested capital in very, very reasonable margins. And we were using very, very conservative assumptions in our business case. And if you want actually more details about that, we're more than happy to provide it. But we were even factoring things like erosion, for example, at the rate of 15% year on year. So we really did test this on an economic case. So I think we're very excited about the technology. We think there are key considerations. One is, how do you surgically deploy it? What are the drivers for the technology within those particular zones? Do you actually understand what is the technology that's moving through those zones and the behaviors of the individuals that are within it? And what are the lateral potential for that if you're mixing B2C and B2B environments? So really, really exciting. The other thing, as I said before, is high consciousness. I think it's extremely important that if a subscriber is moving into that zone, that they're very much aware of that. Yeah, it cannot be that they have to do a speeds and feeds test on their own device before they're actually conscious of that. If you do that, I think there's a great opportunity to monetize far more intensively. So with that, thank you very much.
Thank you very much, Stephen. Next up this morning, we have Peter Moberg, who's head of massive MIMO radios at Ericsson.
Hi everyone, can you hear me? Hello. Okay. Great to be here. Great to see a lot of people. This was my first flight in 2 years, and we talk a lot about hot zones, right? It was great to just arrive at the airport, a lot of people, being on a plane, arrive in the arrival hall, being in Barcelona as a buzzing city, and just being in a room like this, which is also now a hotspot. One of us even said it's even great to be in a Barcelona traffic jam because that was so long time ago. But that was only the first day. Then the second day we were all, back to complaining. So my name is Peter Moberg. I'm head of the massive MIMO radios. And just to relate back a little bit to Philippe, he talked about these components that you need. And I will give a little bit more on the infrastructure angle on that as well, because that's another important factor, obviously, to build a 5G network, including mmWave. So to kick off, in Ericsson we have our mobility report, and we have actually seen that in the last 10 years, the mobile traffic has increased a factor of 300 times compared to 10 years back. And we predict that by 2027, it will be another factor of 5. So obviously, mmWave with the wider bandwidth and the capacity that brings, we believe that will be a very important component of a 5G network today and into the future. We know already that this bandwidth also brings great opportunity for new experiences. So we're talking gigabit speeds on downlink. We'll also talk about that we're coming to gigabit speeds also on the uplink now. And as Philippe was touching about, we also believe that mmWave is complementing the other parts of a 5G network. So on the right side you see the low band for coverage, wide area. You have the mid-band, which is kind of a bit of a sweet spot between capacity, user experience, and coverage. And that's where there is a lot of momentum today in the deployments worldwide. And then, mmWave bringing this additional layer of capacity, user experience, and an opportunity for new use cases today and into the future. And an important aspect is that if you coordinate them, if you use dual connectivity, for instance, you can improve that experience even another dimension. So an interesting thing from our perspective is that we already see a lot of different deployment use cases already today. And that's what you see on the left side here. So you can, already today, we have mmWave deployments going on rooftop, reuse of existing sites. And you're able to do that, and you can reach good population coverage if you have a reasonably dense network already from the start. The second one is you can also go on street level and more take another layer when you go and deploy mmWave. So that's on the bottom here. And then, we also have the venues and the indoor areas where there's also a lot of deployments already today. And from a portfolio perspective, infrastructure perspective, we have a lot of products on display in our booth, and it includes products basically for all these type of use cases: rooftop, street, venues, and indoor. All of that is already there today, and we have already experienced a couple of years on the deployment experience side. So I think that's an important takeaway. And of course, when you have this in place, it brings down more use cases. One is the more traditional, you can differentiate on performance. So I think we talked about the Net Promoter Score and that kind of thing is a very important component. The other one is the hot zone and the experience in a crowd, which touched upon that. Fixed wireless, I will talk about that more on the next slide. And then you also have the more enterprise use cases with connected enterprises like mines or ports or manufacturing, when you can use this low latency and this extreme experiences to support those. If we talk a little bit more about one specific case, the fixed wireless, I think there's a couple of points here. We've touched upon some of them already, but in this use case, when it's when we have a line of sight kind of deployment, you're not really limited to this, maybe more what you think about mmWave. in the low 100 meters. But you are actually able to sustain up to gigabit speeds on a kilometer distances. So that's important. And you do that with a high power solution, both on the radio product side as well on the CPE side. And then from a business case perspective, especially combining it with midband, that's what you see on the right side. So those two together, you can really bring a wireless fiber experience. You can remove this that you have to kind of tier it in different speeds, tier it in different data buckets. If you have these two, you can serve where it's applicable and you have line of sight, you can serve them with a millimeter wave. And where you don't, you can fall back to midband. And both of them together will bring all customers the experience that they are expecting. So we kind of all know that millimeter wave brings like gigabit speeds on the downlink, and we have seen 5G, and we see speed records being breaks all the time. Here we focus a bit more on uplink. I think we are approaching, and we're actually passing this kind of astonishing milestone with also gigabit speeds in the uplink. And why is this important? Well, we have these crowded events, we have venues, and that's already kind of well known when we look at data consumption on these venues during events, that everyone is taking so many pictures and they're filming things, so that the uplink traffic is actually the dominating part in many of these sports events. And that has been there for a few years. So then that becomes an obvious use case for supporting higher uplink capacity and throughput. You have the media production and live streaming when you do live kind of on the field production. We have the mobile broadband use cases with AR, VR, and we have the next wave of enterprise opportunities. And we have more of this also. These some things we have on display in our demo area here at MLWC. We also have a demo on this particular use case where we are kind of reaching the uplink speed of up to a gigabit. And this we do together with Qualcomm. And the technology component here is that we are combining, as you can see, 4 millimeter wave carriers. So that's kind of 4 carriers aggregated on the millimeter wave side. And then we also have the NR dual connectivity, adding it together with a midband layer. And that's how you reach up to now 1 gigabit per second in the uplink. So this is something we have a demo in our booth. Okay, to summarize, I think also important to note that this is not really a brand new thing anymore. It's not only a research concept. We have had commercial networks now for multiple years. We're already in multiple generations on our side, on the product side, and also on the handset side. And we talked about this growing ecosystem, which is continuing. And all of this put together with the features coming out and the new capabilities of the network, we believe this is now the time to unlock new and demanding use cases. With that, thank you very much.
Thank you very much, Peter. I'd now like to invite my colleague, Federico Agnoletto, Senior Economist at GSMA Intelligence, to the stage.
Wow, feels good to be back on stage. So, I'm Federico, an economist at GSMA Intelligence. We are the analyst arm of the GSMA, and we provide data research and analytics for the mobile industry. So, the pros and cons of millimeter wave, right? I think you all know short range, penetration difficulties, new deployment strategies required. But there's a lots of bandwidth available, high speeds, and contiguous spectrum available there. So is it cost effective? We have developed a TCO model that takes into account a range of factors, population density, data usage, busy hour, market share, spectrum, coverage requirement, performance requirements. And we look at different scenarios. The dense urban one, we compare midband versus midband plus millimeter wave. And we see that it can be cost effective in a range of scenarios. 5G FWA, very excited about that. So we compare both midband plus millimeter wave versus midband and millimeter wave versus midband. And we find that the results are particularly sensitive to the ULDL traffic ratio. Speaks to what Peter was saying before on the uplink side of things. And that it can be cost effective in urban, suburban, and rural areas. And we also compare 5G FWA versus FTTH on millimeter wave only and on millimeter wave plus midband. And there's a new report coming out today, so look it up. We find that it can be cost effective in a range of scenarios, both millimeter wave only and midband plus millimeter wave. Millimeter wave only, it's cost effective normally when in a range of scenarios when you need to pull your fiber cables in infrastructures that you need to build. So you need to build the ducts or the poles, then makes sense to deploy 5G FWA on millimeter wave. Indoor scenario, this is pretty interesting. I think you've heard of the connected 5G laptops announcements, right? So they're coming in the world of work from everywhere, I guess. If you work from the Bahamas, I wouldn't. Anyways, so, it's the concurrent demand that drives this. The more devices are active at the same time, the better the cost savings, the more the cost savings delivered by millimeter wave. So it's all about this concurrent demand. And, there are obviously lots of other sensitivities that we look at. So please read our reports. Finally, we also do some work on, how 5G lifts the economies, about, productivity improvements that drive GDP growth. So we also look at how millimeter wave is going to enable economies worldwide, and we estimate that the impact is going to be around $200 billion in terms of enabling GDP growth. All right, so dense urban, 5G FWA, indoor. These are the key takeaways. And recommendations. Operators, please do not underestimate the role of millimeter wave in the short term. It's just about time. You will need it sooner or later. We suggest governments we recommend governments to make clear plans for assigning the millimeter wave bands so that operators can start to understand the technology. And vendors, obviously, please, scale is key, so we want the cost of the equipment to go down. So if you want to read more, like I said, there's a new report coming out today, right after the Millimeter Wave Summit on 5G FWA, and these are the range of reports that I've just talked about in 10 minutes, which summarize a bit like 2 years of work. So, all right, thank you. So I want to invite Brian from Verizon on stage. Brian leads the device technology and sports innovation at Verizon. Brian, you want to come up? Shall we get a chair? All right.
Let's get Federico a chair, so I'm not done with that. Principal's office. Hello, everybody. You're kind of a boring crowd. Let's get excited. We're going to talk about cool stuff. Yeah, okay. Alrighty, thank you.
All right. So Verizon, sports. Why is 5G cool for sports, Brian?
Yeah,
Tell us
all
a
right.
bit.
So I think you guys have gotten a lot of really good inputs here today. I think that the people who have gone before me, they told the story. They absolutely convinced you about the efficacy, the power of 5G, how 5G millimeter wave is doing great things, where it's headed, Federico. I think your economic report was great. I think between Bell Labs and Ericsson and the GSMA people and our CTO that came up and Qualcomm, I hope you get it. Millimeter wave is here, and it's going to do great things, and it's very exciting for the industry. And I think why they wanted to invite Verizon up here is because what we've already done with it for sports. And so we want to talk to you today about 5G built for sports. So take a look at that right there. That's something that we did at SoFi Stadium. Does anybody know what SoFi is? 3 of you. Okay, great. It's an international community. So SoFi is the Los Angeles Rams and the Los Angeles Chargers. Those are 2 football, not football, right? So these are people that play with the ball. They kick, they catch. It's football, but American football. Okay, so this is the Oculus here. This Oculus up inside of here is massive. It's one of the biggest in the world, and it is eye candy. It's amazing to look at. Guess what's inside of here? Just take a guess. What's inside of that Oculus? Millimeter wave radios. Wow, you are so good. You are so good. I love it. Okay, we put over 140 5G millimeter wave antennas inside of this facility. Why? Why do you think we did that? What was the big deal? Capacity for what? For uplink, for sharing, and there was a game that was played there. 106 million people watched it. What was it? Super Bowl, yes, all right, yes, we got some excitement from the crowd. Okay, so sports is very exciting, and inside of this location, you heard about venues and malls, you heard a lot of positive things about millimeter wave. We did this in February, this month. We did this for a lot of fans. We did it for this big game, and inside of that game, Federico, all the people inside of there were able to access high-capacity video. They were able to access high-capacity Snapchat lens. They were able to access video games where they were playing in real time with no latency against each other. So everybody in the room knew what everybody else was doing when they were playing a game called Ultra Toss. And so you're trying to throw a football into the middle of the field. It was an experience you can't have without millimeter wave. You need that massive capacity. You need an absolute huge amount of low latency and big capacity for this many people to be able to enjoy and interact with each other. So that was super cool. That got a lot of people excited. How many people watched the halftime show at Super Bowl? Okay, so again, international community, maybe 20 of you, all right? But guess who showed up? The first ever $1 billion rapper. What's his name? Anybody know?
Dr. Dre.
Dr. Dre, yes, Dr. Dre showed up, and a guy named Eminem, and a guy named Snoop Dogg. Okay, so maybe you don't listen to rap music. But anyway, so the halftime show, we put an 8K video, a 360-degree video, and we called it a portal. And inside of that, we were able to broadcast something people had never been able to do before. When you watch the halftime show on Super Bowl, you watch it through a single pane of glass, and it's what the broadcaster wants you to see. But with 5G millimeter wave, we were able to broadcast something people could control themselves and personalize. They were able to completely see inside as if they were there on stage. How cool is that, right? And it was very cool. And this was with all sorts of rappers that were super famous. They sang the song California Love in California with a bunch of people from California. That was cool. That was very exciting. It got people very amped up. So we had over 250,000 people looking and watching as if they were on stage. Can't do it unless you have millimeter wave. It was very exciting. Okay, so I'm very excited about this, you can tell.
So awesome, yeah. Can you tell us a bit about how you're working with teams and leagues to innovate? Right?
Absolutely.
What's your strategy there?
Yeah, let me tell you about our strategy. So take a look at this right here. Okay, so our 5G strategy comes around these strategic pillars that you see on the screen. First off is next-gen video. I just talked about how you can watch lots and lots of video on millimeter wave. So in the NFL and stadiums this year, we have something called multi-view. It's 7 streams of 1080p to your phone. So you can control what you're watching. If you're high up and you want to see the 50-yard line, if you're on the end zone and you want to see the other end zone, you can control all of that. It's personalizing the experience in sports like never before. So that next-gen video we did with the portal, we do all these things so that people don't have to sit and just look at the Jumbotron and let somebody else control. Because today's generation, the younger kids, they always have that second pane of glass in front of them, and they get distracted. They don't want somebody else controlling it. They want to control it. They want to personalize. So 5G mmWave lets you personalize massive amounts of video. Let me give you some technical perspective. We did this during COVID. When we sent it home to the house, we broke the ISP and Wi-Fi. We broke it. It couldn't handle 7 streams of 1080p, so we had to dial it back to 5 streams of 720p, and then it's okay. But when we did 7 streams of 1080p, the Wi-Fi got sick, okay? So you have to have mmWave with massive bandwidth to be able to do the kind of video we want to do. Okay, so I know I'm getting excited here, but let's talk about what we're doing with, I talked about multi-view, our portal experience. We actually broadcast the Super Bowl last year over 5G. So think about the significance of 100 million people watching something, and we had a 5G camera, and it was broadcasting. Broadcasting. The live Super Bowl. Very exciting. All right, now, next up, I want to talk about, I know you've got questions, but I got some more I got to hit here. So I got real-time player tracking. We are doing things with players in sports leagues we couldn't do before. Because Wi-Fi networks, 4G networks, they can't keep up with the kind of latency and the kind of speed and movement. Players in some leagues move at plus 20 miles per hour. It's very fast. And so in order to be able to track the players and see what's going on, you need a connected edge and a 5G mmWave network to really keep up with that. All right, and then the Verizon communication of the future, or sorry, Venue. I love Verizon. The Venue communication of the future. We're building, I'm going to show you a stadium. We're building things in Venue that you couldn't do before mmWave, Federico.
Super cool, Brian.
Yeah, it's pretty exciting.
So, you know, what about the Phoenix Suns? What are you guys doing with the Phoenix Suns?
Yeah, let me tell you what we're doing with the Phoenix Suns. So we got a little video we're going to play here.
The 5G Performance Center is really a
turn up the
basketball
volume?
playground. It's a basketball laboratory where we get to ask a lot of really smart, intelligent questions. And for the first time, Verizon and its technology really allow us to be able to answer those questions through really integrated research.
They're the leaders in technology. They are a company that's been doing this, edge computing and things of that nature for forever. We're just getting into that here in sports. We have everything here at the Performance Center that an athlete could wish for. We invest resources, our players invest time. And when they come here and they see that there are so many things they can take advantage of, and they have so many things at their disposal, they view this as a place where they can improve. I'm proud of the way you guys compete. All you guys, you know how much I care about you. We got more to do and there's more to come.
One of the most exciting parts about the first phase of the research that we've been doing here is really developing what we call a shooting lab, which is really in-depth analysis of how well our players are shooting the ball, as well as the mechanical components of how they're shooting the ball from a body perspective. It's exciting to think what we're going to do once the machine learning comes online, once the edge computing comes online, to a degree that we can really start measuring in real time motion capture 5-on-5 basketball, some of the other kind of grander projects that we have on our docket.
it challenges us to be progressive and to think forward. So having all of those tech capabilities has helped us figure out how to build a good team. Our guys want to win, and they want every edge possible. And this will allow them to perform better. And ultimately, if they do that, we'll have the success that we're experiencing right now.
It's over. Suns win.
All righty. Yeah, thank you, Philippe. All right, so what you saw there was the NBA Executive of the Year last year. He won. They went to the finals. They were up 2-0 in a 7-game series, but they lost to the Milwaukee Bucks and the Greek freak, Giannis Antetokounmpo from Greece. And so James is the NBA Exec of the Year. He won a 3-point championship. He won 3 championships with LeBron James. And so he's a very good executive of the Suns. He has a good vision to merge tech with his players. And you can see ever since they've entered that facility, they're winning 75% of all games. They have 2 players shooting in the top percentile, top 5 of 3-point shooting in all of the NBA. Because we took, millimeter wave isn't magic, but we took millimeter wave and we merged it with other technology. So we take cool sports tech and we mix it with 5G millimeter wave. And when you do, you get computing and real-time information that athletes want and they respond to. Makes a big difference.
And it's all about winning, right? You want to win. And
absolutely.
So tell us a little bit, how are they improving their performance with 5G?
Yeah, so one of the things that we've seen happen is players are very stubborn at the professional level. They think they know best. But most of them grew up with these little black rectangles and they trust them. They trust the science that comes from this. And so there was a player last year during the playoffs that got injured, and they said, "We need you to take a break." And he said, "No, I can't take a break. I have to, keep shooting." And they showed him that his performance was below NBA. It was subpar NBA capability. He took a break. He came back, had the best shooting performance in the finals. And so when you give them information, you give them biomechanical data, you give them run rates and statistics and trends that normally takes a coach like weeks to gather and to tell them information. When you give it to them immediately, it changes the way they view the world and they respond differently. That's why they're so good. The Phoenix Suns this year right now, #1 in the NBA. They're the top of the Western Conference and the whole NBA. They're winning more than anybody else. And a lot of it has to do with this technology. And they admit that. You just heard him say that. It's very exciting.
Can you please come to Italy and teach Inter Milan as well how to play with the sport?
I like this idea. Yes, we should do this.
Yeah, really looking forward.
Yeah.
So can you tell us a little bit about the deployments into stadiums? A little bit of detail on how you deploy into stadiums?
Yeah, that's a great question, Federico. So I'm going to show you a stadium. I showed you SoFi Stadium earlier. That's where the Rams and Chargers play. But basically, for us, we want to have multi-band in there. We want everything. We want Wi-Fi, 4G, 5G. We want 5G NR sub-6. We want 5G millimeter wave. We want it all. We want edge computing close. Verizon and Amazon have gotten together with Wavelength, and we're putting edge computing as close as we can to as many facilities. We have our player tracking we have going on. We're trying to accelerate frictionless entry just like you have here at Mobile World Congress. And that next-gen video, that makes a difference because people want to personalize their experience in the venue, Federico, and that makes all the difference when you have that kind of capacity.
Of course. And then, what about the fan experience?
Yeah, so let me show you a couple of cool things. This is what multi-view looks like. So on the right-hand side, this shows you right here how you can watch 7 different angles. And in America, you have to touch 2 feet down when you catch the football, or it's not a score. So sometimes it happens so fast you can't see, and you don't want to wait for the broadcaster or the venue to show you. So you come down here and you touch on that, and you can scrub the playhead back and forth, and you can look at it in 7 different angles. You can't deliver that kind of capacity over 4G. You need that millimeter wave capacity. The next one we want to show you here is that with sports betting in the NBA, our first ever we're doing is with the Phoenix Suns, where you can do a parlay. You can bet on 2 or 3 or 4 things, and since you're there and you're seeing things live, you can just click down here and say, yeah, I do think somebody's going to score the first 3 or get the tip off. It gives you experiences you can't have at home. You have to be millimeter wave with lots of capacity to be able to do that. It's very
Yeah,
exciting.
As a sports freak, you can play a lot with that, right?
Yeah, you absolutely can.
Yeah.
Yeah, the big thing I think that I want people to take away is you heard so much amazingness about millimeter wave and how it's changing the world and what countries are doing. We actually are putting it to place and putting it into action in two different leagues, the NFL and the NBA, and the response is super favorable. The press loves it, the fans love it. If you can experience this when you're at a game, it changes the way you think about the football game.
Yeah, I think we all love it. I mean, and what's next then with Verizon? Are you looking into new partnerships?
Yeah, we absolutely are. So we want to take this to venues, for example, where there's a concert and maybe you get to experience that singer that I was talking about differently. Or we want to take it into different sports because we don't want to just only focus on these two. We want to take it to any sport where people want to have a better experience.
Awesome.
Yep.
Well, I think we've run out of time.
Yep. All righty. Thanks, guys, for the support. And thanks for letting us share our fun excitement about this. We really love sports and 5G millimeter wave. Thank you.
Thank you. All right, Federico. Thank you, sir. Yeah. Don't worry, don't worry.
Thank you very much, Brian and Federico. Moving on with the agenda, next I'm delighted to welcome Jaejin Sul, who's Director of the Ministry of Science and ICT of South Korea.
Yes. Hello, my name is Jaejin Sul, Director of the Ministry of Science and ICT of Republic of Korea. What I'm going to present today is a new service case using 5G at 28 gigahertz frequency band. We're still in the early stages in using millimeter waves. And I would like to start off my presentation with hope that through this sharing know-hows and experiences we have, we could get some insights and thoughts to revitalize 5G services in the future. Today's presentation will proceed in the order of explaining the background of the project and the concept of POC utilizing the 5G 28 gigahertz frequency band and its results. As we all know, mobile data traffic is increasing rapidly as the internet-based ecosystem develops. At the same time, the importance of data offloading for distribution of these traffics is growing as well. As one of the great means for this mobile data offloading, increasing the capacity of Wi-Fi is also very important. In Korea, the government evaluates the quality of mobile communication every year. And according to the results of 2020, Wi-Fi communication speed in subway trains was poor at around 20% of that of other areas. One of the main reasons for this poor quality was related to the backhaul capacity of Wi-Fi as LTE was its backhaul. At the same time, multi-access environment in subway cars made it also difficult to get good quality of Wi-Fi services. And that is why we wanted to use millimeter wave and Wi-Fi 6 or 6E to solve this problem. And this is the concept and implementation process of POC in Korea for this project. In March 2021, the Ministry of Science and ICT formed a task force composed of 7 organizations, including 3 major mobile carriers, and began discussion on the directions and plans for POC. In June 2021, with the cooperation of Seoul Metro, we started installing 5G 28 gigahertz AUs around subway tracks, 5G 28 gigahertz CPEs in subway trains, and APs that support Wi-Fi 6E. This installation process was completed around September 2021, and POC began in earnest. This slide shows the diagram of the configuration of the network inside subway cars that is using LTE as its backhaul. Passengers who use Wi-Fi and those who connect to LTE coexist in this environment. The problem here is that there are not enough LTE resources allocated to Wi-Fi APs, and the insufficient resources are shared with the passengers using LTE in the subway cars. Another main problem was that Wi-Fi 5 enabled APs could not handle multiple access environments where dozens to hundreds of people tried to use simultaneously. To solve this problem, the task force looked to application of 5G 28 gigahertz links and Wi-Fi 6 or Wi-Fi 6E. The two main contents of the POC was as follows. First, using 5G 28 gigahertz resources as dedicated backhaul for Wi-Fi service. Second, using Wi-Fi 6 APs or Wi-Fi 6E APs operating in the 6 gigahertz band. Another difference from the past when using 5G 28 gigahertz as a backhaul is that 5G CPE is installed in the engine room located at both ends of the subway trains, and also Wi-Fi APs in the cars are connected with an optical cable. We consider the propagation characteristics of 28 gigahertz band. And here are the results of the POC. In conclusion, when 5G at 28 gigahertz band was used as the backhaul of Wi-Fi, the average download speed was about 10 times faster than when existing LTE was used as the backhaul. As you can see from the figure on the left, the average download speed of Wi-Fi was at around 70 megabps using LTE backhaul, but it improved to about 700 megabps in the POC environment. Similarly, we saw an improvement of performance with about 6-fold or more increase in the upload speed. And the maximum speed in the POC environment was about 1.8 gigabps, which is about 25 times faster than Wi-Fi using LTE as its backhaul. Based on our POC experience and achievements, we are pursuing a plan to expand this service and build subway Wi-Fi network that uses 5G as a backhaul. The main plan currently scheduled is to develop equipment such as portable CPE and Wi-Fi AP more applicable and suitable for the subway environment, and revise the relevant technical regulations by the second quarter of 2022 in order for the service to run smoothly. In addition, we aim to expand and commercialize the service by completing the construction of infrastructure in the subway and the development of equipment inside the cars by the fourth quarter of 2022. This project is the exemplary of the private-public cooperation for 5G 28 gigahertz utilization. Beginning with this 5G project, we expect more public-private cooperation projects to be delivered in conjunction with private ESG management for enhancing social value. Thank you.